Welcome into Topic 6 DQ2. Because there's a lot of different questions and these are going to be in different orders for everyone, I'm just going to go through whether or not these are permutations or combinations, so I'm going to go through columns is the way I'm going to do it. So a lot of reading here in this first part. In a lottery game, 45 numbered ping pong balls are put in a bin and 4 are randomly chosen. To win the jackpot, you need to match all 4 numbers in the order in which they were drawn. So we can actually pause halfway here. So this is saying the order matters. When the order matters, we want a permutation. It'll pop up here. Let's move on to the next one. In a lottery game, 40 numbered ping pong balls are put in a bin and 5 are randomly chosen. To win the jackpot, you need to match all 5 numbers. So notice it doesn't say anything about that they need to be in the order in which they were drawn. It just says you need to have all 5. And so in that case, we have a combination. Order does not matter. Next one, in a lottery game, 40 numbered ping pong balls are put in a bin and 5 are randomly chosen. You'll get twice your money back if you match exactly 3 of the 5 numbers, still using the same number of outcomes as the game above, choosing 5 different ping pong balls from 40. Again, notice this whole thing, it does not say anything about order mattering, and so by default, it is a combination. Next one. 30 horses ran in the Kentucky Derby. The trifecta bet involves picking the first 3 finishers in order. So order matters. So permutation. Next one, 30 horses ran in the Kentucky Derby. The superfecta bet involves picking the first 4 finishers in order. So again, the order here matters, and it is a permutation. All right, so we're going to read these questions over and over again. Feel free to jump around. The one confusing thing is if you there's a problem here where it says, look at the one right above. Sometimes it's out of order and it's the first one, so just make sure you're looking at the other ones that also mention a similar structure in the lottery game with so many numbered ping pong balls. So I will see you in the second part, and we will go through, describe how to calculate the number of outcomes and the total. So I'll see you there in a second. Welcome into part 2. We're going to work through columns C and D. C is describe how to calculate the number of outcomes, and then D will actually be calculating those. So it says, in a lottery game, 45 numbered ping pong balls are put in a bin and 4 randomly chosen. So we can actually stop there. So we're going to say, I'm going to say choose. You can say pick, but choose any 4 out of the 45 we are dealing with ping pong balls. And because it's a permutation, we're going to say where the order, I'll just say matters. If you put order of selection matters, that's also fine. And because we have a permutation, it is going to be equals, there's a built-in function, PERMUT for permutation. We have a total of 45 ping pong balls, and we are going to permute 4 of them. Next one says, in a lottery game, 40 numbered ping pong balls now are put in a bin and 5 are randomly chosen. So we're going to say choose, it's going to try to reference the previous one. We want 5 out of the 40 ping pong balls. And because this is a combination where the order does not matter. And now, because it's a combination, we say equals, the built-in is COMBIN for combination. We have 40 ping pong balls. We want to choose 5 of them. Awesome. Now this next one here, if you read them, the success is going to be different. However, the actual total outcomes, it'll even tell you here, still using the same number of outcomes as the game above. Right, now, if you're unfortunate enough to get this one at the very top because it does mix up the order, just realize that it's referring to a problem in your problem set when it's saying it's the same as the other one. So, same thing. Choose any 5, and it's going to autofill for me, which is perfect. Choose any 5 out of the 40 ping pong balls where the order does not matter still. And it's, again, going to be combination. 40 ping pong balls, we want to choose 5. All right, so these two should be identical so far. They will end up being different over here, but so far they should be identical. We have 2 more. 30 horses ran in the Kentucky Derby. The trifecta bet involves picking the first 3 finishers. So we can say choose any 3 out of the 30 horses where the order matters, since it is a permutation, and equals PERMUT. There's 30 horses, and we want to permute 3. And finally, it's the same exact question, but now instead of picking 3 horses, we're going to pick 4. So choose any 4 out of 30 horses where the order matters. And again, it's a permutation, so equals PERMUT. 30 horses is the first argument, and we want the 4 finishers. Enter. So that is it for these first 3 columns. I will see you in part 3, where we will go through, describe how you can win this game, and the total number of ways you can win. So I will see you in a second. Let's go ahead and jump into part 3. We're doing column E and column F here. In column E, it says, describe how you can win this game. And we're going to go over to our possibilities here. In a lottery game, 45 number ping pong balls are put in a bin and 4 are randomly chosen. To win the jackpot, you need to match all 4 numbers in the order they were selected. So in order to win, that's essentially we're just going to repeat exactly what they just said. Pick all 4 ping pong balls in the order they were selected. And if you have something to this general idea, that's going to be okay. Now let's actually think about it, because you'll notice these ones are green, which means just enter in a number. And so you can imagine a number comes up on a ping pong ball, you chose it, and you continue to do that. So think about how many ways are there to actually choose those 4 numbers in that specific order to win. Well, there's only one way to do that, right? So if I told you the winning numbers were 27, 50, 23, and 13, you would have to pick those specific numbers in that specific order, and there is only one way for you to win if you do that exactly. And so we just have to enter in a 1. The next one is, in a lottery game, 40 numbered ping pong balls are put in a bin and 5 are randomly chosen. To win the jackpot, you need to match all 5 numbers. So to win, we need to match all 5, but it does not say that we care about the order. That's why it's a combination. So pick all 5 ping pong balls. We'll just say where the order does not matter. So you could name 5 ping pong balls. There's going to be only, again, one way to choose those. There were 5 winning ping pong balls. You selected all 5 of them. So there's only one way that can possibly happen. So we're going to say, again, 1. And you're going to see a common theme here with these green cells. The next one, this one's going to be a little bit different. So this one is, notice there's an actual formula here. So it says, in a lottery game, 40 numbered ping pong balls are put in a bin, and 5 are randomly chosen. You'll get twice your money back if you match exactly 3 of the 5 numbers, still using the same number of outcomes, etc. Okay. So we want to do choose 3 out of the 5 winning ping pong balls or numbers, whatever you want to put. And so the way we need to think about this, it's obviously different than all the other ones, is we need to choose exactly. Let me add that keyword in there because that is important. Choose exactly. So the way we do this is it's a combination question. And I'm going to do it step by step. You want to think about this as a series of decisions. So we're going to say equals COMBIN for combination. There are 5 winning numbers, and you selected 3 of them. Okay, but we're not done yet because now we've selected the 3 winning numbers, but we still need to select 5 overall numbers. So that means, let's do another combination. Well, if there's 5 winning numbers out of the 40 total numbers, that means there are 35 losing numbers. And if I chose 3 winning numbers, that means I chose 2 losing numbers. So think about the first combination is the 3 winning numbers that you chose out of the 5. And the second step there is choosing 2 losing numbers of the 35 that were left over. Enter. Let's keep reading. We have our horse races for the last 2. So it says 30 horses ran in the Kentucky Derby. The trifecta bet involving picking the first 3 finishers. So we have to pick exactly those 3 finishers. So we're choosing the first horse correctly. So choosing all 3 horses in the correct order. And it's okay that I accidentally did this to my box, so don't worry that it's a different color than yours. And again, same thing with these green boxes. There's only one way for this to happen. I have to choose all 3 of the horses in the correct order. There's only one way to make that selection. Oh, I put 3. 1. And same thing here. Choosing all 4 horses in the correct order. And again, there is only one way to make this happen. We have to choose all 4 in the correct order. So that is it for column E and F. I will see you in the last 2 columns. We'll do these together, and G and H. Last part, we actually don't need to read the problems anymore. We have all the information we need. And so it says the probability of winning. And if we do this box correctly, it'll help us with the rest. The probability of winning is going to be equal to how many times we can win, which in this case is just unfortunately once, divided by all of the possible outcomes. So we're taking the number of successful outcomes, in this case 1, and we're dividing it by the total. Enter. Very, very low percentage. And again, if we've done this one correctly, we can drag down because all these boxes are going to be the same, right? It's going to be the successes are in column F, the totals are in column D, and so we can just drag down and it will check all of these. And then finally, the odds against winning or odds of failure are going to be equal, and it tells you actually right there. So we have parenthesis 1 minus P, which we just calculated, end parenthesis divided by P again. Enter. Now for the ones that have just a 1 for success, you're going to notice that here's the success, here's the odds against winning. Those 2 values add up to the total. And that's because when we talk about the interpretation of the odds, it's always the odds of winning versus the odds of losing in their simplest form. So if this is already 1, we can't simplify this anymore in terms of the ratio. And again, we can continue along with the rest of these. Calculate it in the same way. You're going to notice all the ones that have 1 for the green text box. Again, those are very nice. They're already in the simplified ratio. The one where we actually had to calculate, there's some simplifications that we can make. And so it simplifies down to the odds of 1 to 110. And so that is it for this DQ. Only one more week of DQs. So I will see you in topic 7.